Is in a very good mood, not feeling sleepy. So yesterday we are through with what exactly is the data, why should we collect the data, how can we collect the data, how can we collect the data from several sources like primary and secondary sources. We use the methods of collecting the data by using primary sources and by using secondary sources. And after collection of the data, we should check it for completeness, consistency, and relevance. These are the things that we have discussed yesterday. So we are with our data. So how can we go further, or what should we do with that particular data? Whether it is possible to do with that exactly the data that we have collected is raw data. So today we will be discussing about how can we organize that specific data and present it so that a decision maker can face no problem in making his or her right decision. So going forward, we will be discussing about organizing the data that we have collected yesterday. So here we go. So exactly the data that we have collected are raw facts, figures, observations or measurements which can be used for our analysis, and we collected that for by taking into consideration the purpose. So it forms the foundation. That particular data that we have collected is the foundation. But whatever we have collected is in its original form, that is in raw. That means we have collected it through questionnaires. Each and every questionnaire is containing the data about a specific object of our purpose. So those are in your raw or unorganized data. So that raw data, which is often very huge or very voluminous, and it appears to be complex. And by taking those questionnaires as such, a bulk of the questionnaire, maybe 50, maybe 100, it is very difficult on anyone's part to make any decision or interpret it directly. So for that purpose, we require, or to make your data more meaningful, it need to be organized. By organization, I mean we need to classify it, we need to tabulate it, and we need to present it in such a fashion that the decision maker can be in a position to visualize whatever the data is required for him at a glance. Okay, so organized data helps in identifying patterns, relationship, trends, and it forms the basis for your statistical analysis, interpretation, and of course, policy decisions. So these are the specific, or this is the process through which your data organization basically goes. The data that we have collected through our questionnaire is raw data which need to be classified according to a certain criteria. That means we will be grouping it, taking into consideration the categorization which will be suitable for the purpose of decision makers. And after classifying or after categorizing, we will be presenting it in a table, and that particular table can further be presented by using your graphs or charts, and those graphs or the charts can be interpreted for the analysis, or they can be providing you certain analysis and insights into your action. So what do we mean by exactly the classification of data? By classification of the data, we mean the process of arranging the raw data into groups or categories based on certain common characteristics, or else we may call it as a criteria. So it helps in simplifying large or complex data that is become easy to understand and analyze. Okay, and once you classify your data, it looks very comfortable for your eyes to grasp or to perceive or to, you may say, conceive something from that. And classification is the first step in statistical analysis before tabulation, charts, and interpretation. So, what exactly? So, classification of the data, the example is, suppose say we have taken into consideration the marks scored by a group of students. So, over here I have taken just 10. Okay, instead of keeping the data in that specific form, suppose say I'll present it that in which range of marks, how many students, that means how many students have scored more than 80, how many have scored 70, more than 70, 70 to 80, and so on and so forth. Then I will be classifying the data taking into consideration the marks scored by the students. And this grouping of the raw marks is called as, it is classified into or grouped into class intervals, and this is called as your classification of data. Okay, moving ahead. So, what are the basic objectives behind classifying the data? The number one is to simplify the voluminous data, the large and complex data, which can be organized into a manageable groups, making them easier to understand. Your classification further facilitates in comparison between different categories of the groups, and it reveals the patterns and trends. Classification helps you to identify the relationships between the variables, the pattern that you're, suppose say you are classifying the data according to a specific, suppose say you are taking the record of the sales of a specific product in a specific, according to the specific years, that is 2019-20, 2020-21, 2021-22, and so on and so forth. So by classifying the data according to the time or the chronology that they happen, you will be in a position to visualize what is exactly the trend of the sales of your product during these years. So it reveals the patterns and trends, and it, you may say, classification is the basis for your statistical analysis. It provides the foundation for further statistical techniques such as your frequency distribution, graphs, and measures of central tendency. The better presentation of the data, that means by classifying, you will be able to present the data clearly in tables, charts, and graphs. So basically, we are having, really there are several categories of the classification. You may take any day-to-day activity, like suppose say you are a working professional, so you are maintaining certain records, then you can categorize your records into files and keep them in files. So you will be categorizing those records, like suppose say certain records are very regular or financial sort of thing. Certain are belong to your human resources, or you may say establishment section. Certain will be some, say, critical activities or critical information about your organization. So these are the categories of your classification in any working organization. But basically, broadly, you may say your classification is of two types. Data can be classified in four several ways. Number one is your qualitative, that is based on attributes or qualities, maybe gender, male, female, literacy, literate, not literate, or occupation, employed, not employed, government service, private service, retired, so on and so forth. And number two is quantitative classification. That means all those measures which can be expressed in numerical values, like your age, your income, the score in the exams, and so forth. And one more is your chronological classification based on the time of occurrence or based on the sequence of the time according to which the things are happening. Example may be population, well, or you may say the census or population growth by year, which we study in a decade. And geographical classification based on location or region. That means production by state or district. Okay, moving forward. So your qualitative classification, as we studied, as we discussed previously, it is based on the attribute, based on a specific characteristics. Suppose say I have collected the data of 50 or 55 students, then I have categorized them and boys and girls or male and female. So here I have classified the data based on the attribute that is gender. Okay. So quantitative classification, data is classified based on numerical values or measurable characteristics. So I have categorized over here the marks obtained by students. So 40 to 45, the number of students scored is 40 to 50. 5 number of students have scored marks between 40 to 50, and so on and so forth. This is the classification, quantitative classification. Then the data classified according to time sequence. Suppose say I am noting or I am recording the production of a produce in tons during the year 2021. Suppose say the produce is 150 tons, 22, 180, and so on. So this classification shows the changes over time. And geographical or spatial classification, the data is classified based on a region or a location. Suppose say the rice production of several states of India, I have taken over here 3. One is Odisha. Suppose say it is rice production we have recorded Punjab and West Bengal, and if we will be putting it, classifying it according to the states, then it is our geographical classification. So, yeah. So after classifying the data, we will be presenting them in a table. Okay. So by tabulation, we mean it is a process of presenting classified data in the forms of table consisting of rows and columns. It helps in systematic arrangement of a data for easy understanding and analysis. Your tabulation follows always, means after your classification is over, you are supposed to present your data in tables. The table is nothing but a tabular format. So that means presenting your data in rows and columns, arranging your data in rows and columns. So your tabulation follows classification of the data and makes large amounts of the data concise and organized. So looking into that particular table or the data in your rows and columns, you will be in a position to visualize something, and you will be in a position to decide what sort of analysis or statistical tools you will be using to analyze your data. So each column in that particular table represents a particular category, and we call that as a variable, and each row represents a observation or a groups of data. That is, suppose say we will be tabulating the data of the students, those have taken admission into a specific course in a specific university. Then the course, suppose say in a BCom, the number of students are 40, in BBA the number of students are 35, in BA the number of students are 50. So this organized presentation of the data in a tab form is called as your tabulation. Okay, the number of students in different courses that is recorded in any university or a college. So what are the basic advantages of your tabulation? Large data in a small form. simplifies your large data sets. And by looking into, you can be in a position to compare the things, compare the variables, and it helps in statistical analysis, and it provides you a clear and systematic presentation. So while presenting it in a table, when we present it in a table, our statistical table is having certain parts. So number one, this one is your, sorry, the first, each and every table should have a title. And suppose say you are having certain figures and you are presenting it in numbers or in say rupees, whatever, or in thousands or in lakhs, that is what head note. Sometimes we write no in column figures presented in this particular table are in lakhs. That is your head note. And the number of students or a course that we have written, that is called as your caption or column heading. And the, each row is called as a row head, or each row is maybe called as a stub, and all the rows together, the records in the table are called as the body of the table. And below the table, everywhere, we should not forget to present. If we are marking anything with asterisk, then that asterisk or footnote. Okay, suppose say a BCom 40 and I will be putting there a asterisk mark. Then I should specify below the table what that asterisk by mean. So suppose say I say that includes all categories of students. Okay, maybe full time, maybe part time, maybe general, maybe categories, and so on. And again, below that particular table, I should have the source from where I have collected the data. Okay, so this is a simple description of each part, that is table number. Each and every table should, in your document, should contain a table number, table 1. Each table is given a serial number for easy reference. So in the future analysis or interpretation, while you are interpreting, you can refer to the table number 1. It helps in identifying and locating the table in a report or a research paper. And table 1, and that is whatever we will be writing against it is called as your title, which describes what exactly the data in the table is about. It should be clear, concise, and self-explanatory. Suppose say distribution of students in different courses during the year such and such. And head note provides additional information placed below the title, and it often indicates units of measurement or scope of data. For example, figures are in thousand or so. Moving forward, next is your column headings. They are called as your captions. These are headings of your columns, and they indicate what type of data is shown in each column. Course, number of students here, course and number of students are the captions. And stub, the next item in your table is your stub. The column headings are called as captions, row headings are called as stubs. Okay, the stub refers to the leftmost column of the table, and it lists the categories or items of being described. So here your BCom and BBA are part of the stub, and BCom 40, BBA 35, this is one row, and course and number of students are column captions. Okay, and body contains the actual data or numerical values. It represents the intersection of rows and columns. 40 is the number of students of your BCom. Okay, so this is your body. And footnote provides additional explanations or clarifications about the data. They are always placed below the table. Like figure includes regular students, whatever. And then source, this indicates where the data has been obtained from. Okay, always whenever you are presenting the data in the table, it is always advisable that at the below each and every table we have to mention the source from where we have obtained that particular data. So it ensures your credibility and authenticity of the information. Okay, so the example, maybe we write this table below that source is from university records. Okay, moving forward. So one of the specific, you may say, it is in frequency distributions. The frequency distribution is a method of organizing the data into categories or classes and showing the number of observations in each category. And the number of times a value occurs is called its frequency. That means, in the previous example, suppose say I am having a score of 10 students or 20 students, the number of students scored 59 is called, that is number of students scored 59. Suppose say 3 or 4 or 5 students have scored 59. Then that is the frequency. Okay, the number of times a value occurs is called its frequency. So the frequency distribution helps to summarize large data set into a simple and systematic form. So you are having thousands of data, and if you will be counting or if you will be making it in a frequency distribution, then your table will be very concise, a small one, and the entire observations will be in small table. So it makes data easier to analyze and interpret. And we are having basically two sorts of or two types of discrete frequency distributions. One is your discrete frequency distribution and one is your continuous frequency distribution. By discrete, we mean a discrete frequency distribution is used when the variable takes distinct or separate values. That means when we can count each one. 1, 2, 3. Suppose say you are having 10 families in your locality. And in a gated community, you are having 10 houses. And you are making a survey and just noting down the number of children in each and every family. Suppose say you have somewhere it is 1, somewhere it is 2, somewhere it is 3, and so on. So we have collected such 10 values, and basing on that, I'll be making a table. And one of my variable will be number of children. Number of children in a family. Say 1, 2, 3, 4. I'm having 4 children max. So it is 3. That is, I have counted what number of families having only one child is 1, 2, and 3. So it is 3 is the frequency. Similarly, 2, it is 2, 1, 2, and 3. So I am having 3 families who are having 2 children, and the number of children is 3, 1, 2, 3. Again 3. And 4 is only 1. So this is my frequency table, the number of children in 10 families. So here each value is separate and counted individually. So it is a discrete frequency distribution. So moving forward is your continuous frequency distribution. It is used when data values fall within ranges or class intervals. The variable can take any value within a given range, and the data is grouped into class intervals. We will be discussing this just more detailing in a few minutes. Like marks obtained by students, suppose a 0 to 10, we have two students have obtained in the interval 0 to 10. 5 students have scored in the interval 10 to 20, and 6 students scored is between 20 to 30, and 4 students scored 30 to 40. Here marks are grouped into intervals, so it is a continuous distribution. And in a continuous frequency distribution, your data is grouped into class intervals, and these class intervals can also be formed in two ways. One is inclusive class intervals, and one is your exclusive class intervals. Okay. In an inclusive class interval, both the lower limit and the upper limit are included in the class interval. When we are taking a class as 0 to 10, 0 hyphen 10, that is 0 is the lower limit of the class interval and 10 is the upper limit of the class interval. And whenever we are taking the values where both 0 and the 10 both are included, those values in that particular frequency, then it is called as your inclusive class interval. The upper limit of 1 can also belong to that class. Common used for discrete data such as age, incomplete years, marks, number of items, etc. So it is basically represented like this, that is marks 10 to 10, 19 is 5. That means in this 5 number of students, those who have scored 10, those who have scored 11, 12, 13, 14 and so on up till 19. Then those who have scored 19 are also included in this class interval. And similar is the case with 20 and 29, that is upper class limit 19. The marks scored by the 19 is also in that particular class. Okay, so the class 10 to 19 includes values from 10 to 19. And similarly, the rest. Whereas in case of exclusive class interval, the lower limit is included, but the upper limit is excluded. That means the number of this four number of persons that we have taken as height in cm. So in these four persons are having a height maybe 150 cm, 151 and so on, and 159, but it doesn't include 160. The person having the height of 160 cm will be falling into the next class. So in case of exclusive class intervals, your number of this the frequency or the number of persons having the height less than 150, less than or equal to 150 and less than 160 are included in that class, and whereas 160 is included in the next class. Okay, that is exclusive class interval. That means the persons having the upper limit of the class will be included in the next class. Okay, they are not included in that particular class, right? Moving forward, so graphical representation of the data, which refers to the presentation of the statistical data in visual form. Suppose say you want to present your company's data to your manager or to your top level CEO, who can be in a position to read the performance of your company at a glance during the last 5 years, then it is always advisable that you present your data in a graphical form, which will be more appealing for your top level executives. And it helps to summarize your large data sets clearly, and graphs will enable your manager to to understand and interpret it, and the trends and patterns will be quickly visualized, or it can be quickly identified through visual representation. So why should we present our data graphically? To simplify our complex data, to facilitate easy comparison. If I'll be making a presentation of the data, census data of last so many census, like say 2001, no, of course, 1991, 2001, and 2011. Then, if I'll be categorizing each one like male, female, children, and so on for all 3 years, then I will be in a position to visualize the female population trend during these 3 years in my country. That is the trend analysis or trend and relationship that I can be in a position to visualize. It improves clarity and presentation and helps in better decision making. So common type of your graphical representation are bar chart, use it to represent categorical data, that is over here. The male may be one bar, the female may be another bar, children may be another bar. So bars of equal width show comparison between different categories. So the number of students in different courses in any university can also be presented as a bar chart. And in case of, and one more sort of your bar category is histogram. It is the adjacent rectangles, or you may say adjacent bars, and used for continuous frequency distribution. It consists of adjacent rectangles representing class intervals. Basically, the distribution of students' marks. And the pie chart, it represents the data in the form of a circle, and the circle is divided into several sectors. Each sector will be representing the proportion of the total. So basically, the budget allocation to across the departments can be presented by using your pie chart. And one more is line graphs, which is basically being used to study, or if it is a trend, then it can be presented by using line graphs. It speaks about the relationship between the variables, how distributed or how scattered the data are, or how closely associated the data are. So population growth over years can also be presented in line graphs. And frequency polygons, it is used to represent frequency distribution using line segments. We will be discussing the categories of your frequency polygons, less than, more than, in the due course. That means in the coming slides we are having. So moving forward. So these are the several categories of your graphical representations, that is bar chart, histogram, pie chart, line graph, and frequency polygon. Okay. The frequency polygon can be obtained from your histogram. So in a histogram, you mark the middle point of each and every rectangle. Like over here, suppose say 1 point, over here say 1 point, over here say 1, 1 and 1. And if you will be making a connection of all these 5 points, then that is nothing but a frequency polygon. Okay. So going further into your frequency distribution, over here one V is populated more. So a frequency distribution, we will be discussing it in a bit statistical context. So it is a frequency distribution or frequency table is summary of the table of data that shows the number of observations that fall into each of several or non-overlapping classes. Suppose say this is the data of 20 students were asked how many hours they work per week, per day, sorry. Their responses in hours are recorded in a table below. That means this is the 20 students. We have asked them how many hours they are putting on each and every day towards their studies. So using each data value as the class, the following table lists the different values in ascending order and their frequencies. Okay, so this is the class is say 2, 3, 4. That means our minimum value over here is 2. The maximum value over here is 7. Okay, so my class starts with 2 and ends with 7, and then I will be counting the number of. So while making a discrete frequency table, basically what do we do? Suppose say I have taken 2, then in the table I have not included that over here. So I'll be counting 1 and making a mark, a horizontal bar. 2, one more bar. Then this 2 and one more bar, 3. So we are having 3. Those are called as your, and each once I get 5, then I'll cross it. That speaks about 1 unit, that is 5. Okay, so those are called as your frequency bars. So over here I have taken 2. 2 is my minimum number of hours and 7 is my maximum number of hours. So the number of students, they have responded that they are working 2 hours per day are 1, 2 and 3. So over here I am having 3. Frequency is 3 and so on. Similarly, I made a count of 3, that is 1, 2, 3, 4 and 5. 5. Okay, so the number of students responded that they are working 5 hours a day, sorry, 3 hours a day are 5 and so on. 4 hours a day are 3, 5 hours a day are 6, 6 hours a day are 2 and 7 hours a day are 1. So whenever you have prepared this, you should first of all check whether this involves all the observations that you have made or not. How can you check that? So you adopt this frequency table. If it is equal to the number of observations that you are having, then you have not made any omissions. Okay, 3, 5, 8, 3, 11, plus 6, 17, 19 and 120. So we have taken the responses of 20 students. So a frequency is the number of observations in the data that fall into each class. According to the table, there are 3 students who work for 2 hours, 5 students who work for 3 hours and so on. And the sum of the values in the frequency column is, which is the total number of students included in the sample. Okay, and once we have made a frequency, we should also have one more terminology, that is a relative frequency, which is a ratio or a fraction or a proportion, whatever you say. It is the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. That means the total number of outcomes over here is 20. That is 20 number of students responded to our question of number of hours they are putting per day. Okay, and the number of students they have responded that they are putting 2 hours a day is 3. Okay, so the relative frequency of this is 3 by 20 into 100, that is 15%. Okay, what is the relative frequency? It is the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. The number of outcomes of that particular class, or number of hours putting is 2 is 3. Okay, sorry, is 3. So our relative frequency of that is 3 by 20 into 100%. That is 15%. And similar is the case for rest of the classes. And again, if you will be adding up this relative frequency of each, so your calculation is correct if all this will add up to 100. Okay, 15 plus 25 is 40, 40 plus 15 is 65, 65 plus 30, sorry, 25 plus 15 is 40, 40 plus 15 is 55, 55 plus 30 is 85, 85 plus 10 is 95, plus 5 is 100, 100%. Okay, so one more term is cumulative frequency, is the accumulation of the previous frequency. So to find out the cumulative frequency, add all the frequencies of the previous frequencies. Okay. See, over here our frequency is 3, of the class 2 is 3. So cumulative frequency is 3. Of class 3 is frequency is 5. The cumulative frequency of that class will be 3 plus 5. That is 5 should be added to the previous class. That is the cumulative frequency of that particular class. That is 8, and so on. Okay. Sorry. So your cumulative frequency is, to find the cumulative frequency, you have to add all of the previous frequencies to the frequency of the current row. Okay. अभी जो रो आप देख रहे हो उससे पहले भी जितने फ्रीक्वेंसीज है तीनों को ऐड करने से आपका अभी का निकलेगा, as shown in the table. So the last entry of the cumulative frequency column is equal to the number of observations in the data. So that is 19 plus 1 is equal to 20. Okay. Then, so we have done frequency, relative frequency. So cumulative frequency and cumulative relative frequency is the accumulation of the previous relative frequencies. This is 3 and this is 5 plus 3. 8, this is 8, 3 plus 8. This is 6 plus 11 and so on. So cumulative relative frequency, relative frequency of this class is 15%. So this is also 15%. The next one, it is 25%. So over here it should be 25 plus 15, that is 40%. As we did in case of cumulative frequency, the same is the case of cumulative relative frequency. So you to find the cumulative relative frequency, add all the previous relative frequencies to the relative frequency for the current row. Okay. Whatever is there above the current row, all the cumulative relative frequencies should be added up. That will be the cumulative relative frequency of the current row or current class. Okay, the last entry will be 100%. So, suppose say this is the data, which are the number of books bought by part-time college students at a college. We need to construct a frequency distribution table for this data using 6 classes. Okay. So, why 6 classes? As because why the minimum value is 1 and the maximum value is 6. So everything will be in between 1 and 6. So this is the solution for that. So you can work it out. The same procedure. The frequency. So 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 students have bought 1 book. And similar is the case with 10 students bought 2 books and 16 part-time students have bought 3 books and so on. the relative frequency is 11 divided by the total is 11 plus 10 is 21 plus 16 is 37 plus 6 is 43 plus 5 is 48 plus 2 is 50. Okay, it will be 11 by 50 into 100%. Okay, and similar is the case with. So cumulative frequency is 11 for class 1 and 2 is 11 plus 10 is 21, 21 plus 16 is 37, 37 plus 6 is 43, 43 plus 5 is 48, 48 plus 2 is 50. Okay, and similarly this case it is 22, 22 plus 20 is 42, 42 plus 32 is 74, 74 plus 12 is 86, 86 plus 10 is 96, 96 plus 4 is 100. Okay. More deeper. So basically, while that means it depends on the number of classes. So how can we determine the number of non-overlapping classes for our frequency distribution? So this number of classes is somewhat subjective and is often determined by the personality who is making the classification or the tabulation. Okay, so this depends on the person, the researcher, the decision maker who is making tabulating the data. Although there are no rules about how many classes a frequency distribution should have, the general guidelines recommend that it should be between 5 and 20. For a smaller data, use smaller number of classes. For larger data, the large number of classes. So when deciding the number of classes, the goal is to have your classes should be, the number of classes should be enough to capture the trends, patterns, and you may say it should facilitate you in making the statistical calculation in a simple and easy manner. But not so many classes that some classes contain only a very few data values. Okay. So while determining the width of the class 10, 20 or 10 to 9, whether it should be 10 or whether it should be 5, as with the number of classes, there is no hard and fast rule to determine your class width. But however, a general guidelines recommend that the classes all have the same width because this reduces the user may misinterpret the data. Okay, for your interpretation, for your further calculation, the things should be easy and simple. For the purpose, your class intervals or the interval of the class should be, all the class intervals should be of the same width. But however, there is an approximate class width may be found using a small formula, that is maximum data value minus minimum data value divided by the number of classes. Round the number, obtain from this formula to a more convenient number. For example, a whole number. So, if the result of this formula is coming out to be 14.2 say, then conveniently you make the class width as 15. And again, it is always advisable that your class width should be a multiple of 5 to to make easier for further calculations by using that specific class interval. Okay, so how can we determine the class limits? So using the number of classes and the class width, construct the class limits. When constructing the classes, remember that every data value must fall into one and only one class. The lower class limit is the smallest possible data value that falls into the class, and the upper class limit is the largest possible data value that falls into that class. If you will be taking the upper class limit value in the class, then that is called as your inclusive frequency distribution, and if you are taking the upper limit in the next class, then it is your exclusive frequency distribution. Okay, round the number obtained from this formula to a more convenient number, for example a whole number. Okay, and using the number of classes and class width, construct the class limits. When constructing the classes, we should remember one thing, that the data value must be fall into one and only one class. So next is your histogram, which plays a bit major role in your statistical representations. So it is a histogram is a graphical presentation of a continuous frequency distribution. It consists of adjacent rectangles. The base of each rectangle represents the class interval. The height represents the frequency, and there are no gaps between the bars. Okay, 0 to 10. Suppose say this is my frequency table, then my graph will be represented in rectangles touching each other. And we are having two sort of cumulative frequency distribution representations or histograms. One is your less than curve, one is their more than curve. In case of less than curve, it represents the cumulative frequencies calculated from the lower class limits. So calculate the less than cumulative frequencies, upper class limit on x-axis, plot the cumulative frequencies on the y-axis, and join the form of a smooth curve. Suppose say this is my frequency distribution. So less than curve represents cumulative frequencies calculated from the lower class numbers, that is 0, 10, 20. And my cumulative frequencies less than is 3, 8, 3 plus 5 is 8, and 7 plus 8 is 15. Then you you plot your upper class limits, that is 10, 20, and 30 on the x-axis, and cumulative frequency, and the y-axis, that is 3, 8, and 50, and join them by using your smooth freehand. The curve begins from the lowest point and increases upwards. Okay, 10, 20, 30, so 3, 8, 50. Whereas the more than curve represents the cumulative frequencies calculated from the upper side of the distribution. So calculate more than cumulative frequency, plot lower class limits, that is 0, 10, and 20 on the x-axis, and plot the cumulative frequencies, that is 15, 12, and 7 in the y-axis, and join the points from the normal. Over here, it is more than frequency, it is 15, 12, and 7. Okay. So 7 plus 5 is 12, 12 plus 3 is 15. Okay. In that way, we plot the more than curve. So this is your less than curve, and this is your more than curve. And this is the histogram. And this frequency distribution or histogram, if we will be making a smooth and free curve by taking the midpoints of the histogram bars, then we call that as a frequency curve, or else it is called as a oogie. And so less than oogie and more than oogie. Okay, so key takeaways. So the session in which whatever we have covered today is the data. By summarizing the session, I may say that we have discussed that what exactly we mean by the classification. That means the data that we have collected by using our collection of the data chapter are raw data, and those raw data and figures are not in a form which can be used to make the decisions, to present it, or to make it eligible, or to make it enable them to take a good decision or further statistical analysis. We always try to organize our data, and organization of the data can be done by using classification, that is classification, tabulation, and graphical representation of the data. And then we studied that what is exactly the classification means. By classification, we will be simplifying the data. We will be simplifying the data by categorizing our data into several categories. Maybe qualitative, that means we will be categorizing the data by using an attribute. Maybe the height of, sorry, maybe the sex of the students, maybe female, or maybe the color of the students, or maybe the color of a car. And by quantitative, that means all these quantities, all the attributes which can be measured by using numerically measured variables, then we can represent them as a quantitative classification. Suppose say by age, the number of people who are above the age of 50 and so on is your quantitative data. And if we will be categorizing our data according to the time that they have occurring, then we are categorizing, or we are classifying as per our chronological classification. And geographical categories, that means basing on the location or the geographical location of the state or data, whatever is happening, or we are supposed say the sales data of cars in several states of the country, then that is we are categorizing them as per the location. That means the number of cars sold during in West Bengal, Odisha, Bihar, and so on and so forth. And we are summarizing our data by using the frequency. That means after classification, we will be making it in a summarized form by using our frequency distribution. That frequency distribution may be discrete or may be continuous. By discrete distribution, I mean if I can be in a position to count 1, 2, 3, and so on, then that is my discrete distribution. And if the values of a variable are falling within a range, then we call that as a continuous frequency distribution. And your frequency distribution will be summarizing, and it helps in organizing your large data sets effectively. And while making your frequency distribution, your class intervals matter, and those class intervals may be inclusive, may be exclusive. By inclusive, we mean if we are including the value of the upper class limit in that particular class, then it is inclusive. And if we are excluding the upper class limit in that specific class while counting in the next class, then that is our exclusive class interval, which are used depending on the nature of the data. And then after organizing in such a fashion, we are presenting that in a table. And what exactly is the table? In a statistical table, we should have a table number, and to facilitate the report writer to refer to the table by using that table number. And each and every table should have a table title and that table title, and below that, if anything that we are having a common, that is, if we are presenting that the figures in thousands or in numbers, then it should be having a heading, and so on and so forth. We have discussed the each and every part of the table. And then histograms, which are the rectangular representation in of your frequency table in graphs, and bar charts. Each of the bar will be representing a specific variable. And if you are presenting the entire thing in one circle, it is called as your pie charts. And if a histograms, we have plotted a histogram and we are taking the midpoint of each of our histogram bar and connecting them freehand curve, then we call them as ogives. And while discussing, we have discussed less than ogives and more than ogives, and which will be presenting the clear visualization of your data. And finally, we we discussed that your graphical representation, it reveals trends, it will be visualizing your tools, it will enable you to make comparisons, and it will facilitate in interpreting your data in a appropriate manner and making for further analysis easier of your data. So with this, we may say, so this is what we have discussed today. The summary of our chapter is we have taken the raw data, the classification of the, we have made the classification of the data, and we represented our classification in frequency tables organized in frequency distribution, and then we make it a tabulated the data, and after tabulating we presented it in by using several types of graphs. So with this we say this is what we have discussed today. Sure. Thank you.